was getting like a loop thing on my, that's weird.
The audio is, yeah.
We're rolling.
All right, thanks, Will. All right, we'll get started then. It seems like we've got a good number of people. From the Green Bank, I'm Neil McCarthy. We have Lynn Lewis and Sarah Pine here. A couple folks from the Green Bank are also on. Will DeTesto, Mary Vigil, Corey Lesniak, and our main presenter is Richard Duddle. He's a third-party inspector. He has helped design our checklist, and he has been an inspector for probably 12 years on solar and after that battery storage. This is being recorded, so that way, you know, once we're done, the recording will be saved and it'll go out to distribution list that came out from marketing. They have a list of battery energy storage program. So we'll get to table of contents. So introduction, I just did. Richard's going to do probably about 30 minutes of slides and going through different technical aspects of the checklist and the reason why we have these things to be in the checklist and the safety issues and the other considerations that go into the checklist. Towards the end, there's going to be a code labeling guide, which some of you may have seen. It's something that Richard prepared that details like what the labels are supposed to be at storage sites. Just because there are a number of labels that are required, and it admittedly can get to be a lot. So we're going to try to make that a little simpler for everyone. And then we'll go over the checklist that we're currently using, or that we will be using going forward. And then we'll have some questions and comments at the end. I would suggest that, you know, just hold on to your questions, comments at the end. We'll probably have maybe like 15 or 20 minutes. So at the end, you can either put them in the chat or just raise your hand. We don't seem to have too many people, so that we could probably just have you raise your hand and then you can unmute, and then you can say your question. So with that, I give it to Richard. We'll go to the next slide and we'll be in Richard's presentation. You want to start with something there?
Yeah, sure. All right, so we're transferring over from the 2017 checklist to the NEC 2020 checklist, and that includes the IREC in the residential code checklist from 2021, and that's going to be a big change for a lot of people. Next slide, please. So I've done a lot. I'm a former installer. I've been a consultant for a dozen years, and I originally have an electrical engineering technology degree, and that has served me well. Although my concentration was always in instrumentation and not power, but I've learned a little bit since then. So next slide. All right, let's talk about the risks of a battery fire. This is from a shot from a system that's in Australia. So a little far away, it's a commercial site, but fires are definitely a known risk of lithium-ion batteries. And the problem is even if you do everything right, even if you follow all the code, all the manufacturer's instructions, and all the best practices, you could still have a fire. And as a former installer, that's really scary. And lithium-ion fires can be very intense because you can go into a thermal runaway situation, and where one battery ignites the next one and they just keep going. Next slide. So there's three primary reasons why there might be a lithium-ion battery fire. Number one is physical damage. Your battery could be hit by a car. If it's a garage installation, it could be dropped. It could have water intrusion into the battery container. There's a lot that can go wrong physically that can damage your batteries and cause a defect in the battery, which would eventually cause a fire. There's also the possibility of manufacturing defects, internal shorts. We all know the IG Chem problem that caused the recall. That was that. And then you can have a problem with improper charging or discharging. So you have a lithium ion battery and it has a designed charger that goes with the battery. Do not deviate from that. Improper charging and discharging can cause the fire risk that we're worried about. So you must use the matched charge controller that's matched to the batteries. Use only the charge controller that's matched to the batteries, because of this charging discharging problem can cause a fire. The next slide. Here's something you should not do. Let's just give an example. Homeowner calls you to re-rack their existing batteries. They have an older system with lead acid batteries. Let's pick on Sunny Island today, although it could be Xantrex or any number of former systems that are out there. Probably installed 10 years ago. Their lithium ion batteries their lead acid batteries are done. They're at their end of their life. They want to re-rack the system with something other than lead acid, like lithium ion. And lithium ion offers a lot more reliability and a much longer lifespan. Although Sunny Island has a good charge controller, and I'm picking on Sunny Island today, don't use the charge controller unless you know it's compatible with those types of batteries. It's going to have to be listed, basically. Don't use it unless it's listed to do it, because you are the one putting the risk of fire into the situation if you do that. And so somebody calls you up with an old Xantrex that they need to re-rack. Be very, very, very careful before you do anything like that. Next slide, please. So the other thing that can damage your batteries is water. Most of the time, batteries go into basements, and basements can flood. And you want to keep your batteries up and out of the flood water. Just last year, my mother had an inch of water in her basement from a rain event. So batteries are beautifully kept off the floor. Maybe 6 inches off the floor would probably be fine. I'm not aware of any code requirements that require the batteries to stay off the floor, but if you can do that, do that. Nice. All right, let's talk about 9540. So there is a standard for battery enclosures that will provide protection in case of a fire. 9540 is not perfect. It does not guarantee that a lithium ion battery fire will stay in the approved manufacturer's designed case, but it's a lot better than nothing. And for a long time, there was nothing. So what you want to do in this case is you want to use the listed equipment for the batteries. If, say, I don't know, Generac says use this case with these batteries, use that case with those batteries. Same with Enphase and SunPower, just use what is designed and listed to use for those batteries. Older systems, and they're out there, you can still buy and install battery enclosures that are not 9540 compliant. If so, your batteries must be 3 feet apart. And that basically what that does is that will make it so that your one battery stack can't light up the next battery stack next to it if there's a fire. Okay, so because the 9540 is not perfect, you have a sheetrock requirement. And this comes out of the International Residential Code. And you've got to use type X, which is fire rated sheetrock, and you have to protect the area around the battery. Now, what does that mean exactly, the area around the battery? And in some cases, you may have to build a little 2x4 build out to sheetrock around the battery. And in some cases, just having the room, the basement area that it's in sheetrocked is enough. Now, as you know, as solar installers, you're typically not used to working with sheetrock. Sheetrock's not really that friendly for us. Most of us are electricians or solar installers in general, and sheetrock's sort of an afterthought for us. So most likely, you're going to have to schedule a sheetrocker to come in advance of the electricians. And I know as a former installer that adds time, cost, effort, scheduling problems, the whole thing. But it's in the code and we need to comply.
All right, I'm just gonna pull up the code real quick so everyone can see. So this is, oops, this is where this comes from in the IRC code, the requirements for the battery enclosures. As I understand it, all the batteries in our program do have the UL 9540, but these are the IRC codes and do apply for those kinds of batteries as well. I think when you're talking about battery cabinets, that's the enclosure that comes with a battery. This is
Correct.
on top of, this is an additional enclosure that's on top of that.
Right. This is the walls
Yeah,
in an indoor setting.
yeah.
And the battery enclosure is the metal case
Mhm.
that the batteries are designed to be installed in.
Mhm.
Always use the metal case the batteries are designed to be installed in.
Mhm. Right, next slide.
Yep.
All right.
Okay, permitted locations. So batteries can go in a detached garage, which is separate from living space. They can go outdoors. You could mount them outdoors on the side of the house. If you do that, make sure that your batteries are temperature rated for your environment. Most of the newer lithium-ion batteries are designed to go mostly into living space or garages, et cetera, basements. But there are some that can be installed outdoors, and if you do so, you must be 3 feet away from doors or windows. Utility rooms, electrical rooms, that is a permitted location for batteries. Basements, that's where they all seem to go. Garages, that's an acceptable place. You may not install batteries into sleeping rooms or spaces directly opening into sleeping rooms.
Yeah.
And that's the code.
Yeah, and just to sort of like give a broader picture, the intention of the code is to avoid or to contain any fire that might happen so it doesn't get into like living spaces or sleeping spaces.
Right. Remember, any fire that happens can be very intense. That's why there's all of these layers of protection.
Mm-hmm. All right, you ready?
Yep.
All right.
Okay, protective devices. You're going to be required to install a smoke alarm or a heat detector near your batteries. Some places, like for example, near the electrical system in the basement, may already have one, and that's fine. Sometimes you may not. For example, the detached garage may not have a fire detector in it. You're going to have to install one. And as I said before, one of the great risks to batteries is that somebody pulls their car in too far and actually crashes the car into the batteries, which has happened. The solution to that is bollards. And I know that's a kind of a strange word, so I put a picture of what one looks like.
Yeah.
And they need to go in front of your batteries.
So what if the battery is like higher off the ground and there's no risk of a car hitting it? Is that?
Then you don't need a bollard.
Okay, that's what I thought.
Nobody has told me what to do if the battery is going on the side of the garage where the car pulls in, the battery's on the side. So we're gonna not have an answer for that one.
That's fine. We don't have all the answers.
We don't have all the answers.
Right, next.
Yep. Permitted capacity of batteries. This is something you generally don't have to worry too much about because your manufacturer has already thought about this. If you notice that, say, for example, Generac has an 18 kilowatt hour stack. A lot of them are 10s. They basically are already pre-designed to take care of this problem. But there are maximums. For example, if you have a Generac and you want to put 60 kilowatt hours of storage in your utility closet, that goes above your maximum. So you're going to only be allowed to do 40. Each battery stack maxes out at 20 kilowatt hours of capacity. And that's generally already taken care of, like I said, by the manufacturer. If you have a detached structure, for example, if you have a battery shed, which is an amazing thing that I have never seen, then you could put 80 kilowatt hours of maximum maximum of energy storage in the detached structure. Outdoors, outside of your house, you can do another 80 kilowatt hours outdoors, outside of the house. And 80 kilowatt hours outdoors is the maximum for residential. All right. So we're going to talk about labeling a little bit, and I built a labeling guide. Gonna have to make that big so I can read it. A little bigger.
A little bigger. All
A
right.
little bigger. Otherwise, I gotta go back to the car and get my glasses. All right. So this matches up pretty well with the checklist, and it's very user-friendly. I did my best to show what the labels look like, and I will explain the various labels and why they should be. Number one is somebody coming on site, either an electrician or a first responder, should know that there's multiple sources of power on site. And this sticker basically goes everywhere that you would normally interact with. So it goes on the main panel, it goes outdoors at the utility meter, it's likely to be on at least one of your other disconnects. And basically that lets them know that even if they think they've done everything that they should do to shut off the power to the house, like say a fireman pulls a meter, there may be other sources of electricity. This house is still live, and they need to know that. And then, like I said, that sticker goes in a lot of places. Down at the electrical distribution panel, I have to admit, most of the electrical distribution systems are top fed. So if they're top fed, you're already coming through the main breaker. You don't need the don't touch terminals on both the light and load side sticker in that case. But for completeness, I've put it there. The reason being is because let's say you're an electrician and you think that you've turned off the main breaker and you want to work in that box, but the batteries are still alive and feeding that box, you're going to get a shock. That warning is there to prevent that. So you're protecting your fellow electricians when you sticker properly. And just like a regular solar PV system,
Sorry, I clicked the wrong thing.
it's okay.
There we go. Sorry.
Alrighty.
Here.
Yeah. Go a little bigger because I don't have the glasses. All right. So when just like with a solar PV system, you need to label your point of interconnection. So for example, if you're interconnecting into a main panel behind a breaker, and that does happen, even with the newer systems, you want to label that breaker. And because that breaker is likely to be at the bottom of the box, and you're using the 120% rule and all of the things that you might expect, you want the future electrician working on the box to not relocate that breaker, because you don't know who's going to come in behind you. Scroll down. So the beauty of this checklist is that it shows what the stickers look like. This is a plaque. You're going to need a plaque, at least 2 plaques, maybe 3 plaques. Usually a plaque is required at the meter outside, at the main panel, and usually at your hub. I know that not all the systems have a hub, but if you have a hub, you probably need a plaque there. This is a sample. I stole it from an installer, and I stole it from them because, well, I took a picture of it and it's simple. It's not loaded down with junk. It's where's your AC disconnect? Where's your battery disconnect? Where is your main panel? And how to, something that a first responder might need to know when they get on site. Emergency shutoff switch. All you need to label on your emergency shutoff switch needs to be emergency disconnect. And let me go back one page. So I like the concept of the emergency disconnect because all the first responder has to do is punch one button. Just push that button. And that shuts off the battery, it shuts off the solar, and it disconnects the main panel from the street. It's perfect. Not all sites have emergency disconnects. You could have manual disconnects. For example, let's say you're doing N phase. You could have what they call this N phase. They say they have their AC battery. Okay, well, the power is leaving the battery cabinet as AC. You go outside, you have a battery shut off for these batteries, and that's an AC disconnect. And that's likely to be next to the open finger brake disconnect that the utility companies require for the solar. So in that case, everything can be shut off outside from near the meter. You don't need the emergency shut off switch. But the emergency shut off switch is still nice to have, but in that case, it's not necessary. So as the solar requirements require the open finger brake, so the utility lineman can verify that the fingers are not, they can open the box and they can verify that the brake is physically open so that there's no way that the solar power can go back onto the grid when they're trying to repair a transformer or down lines or whatever. There is no such requirement that I know of for any of the batteries, which I find strange, but maybe the utility companies are a little bit behind the times. So you need a disconnect outside that can shut off the batteries as well, and that's code, but it doesn't have to be the open finger brake that the utility companies require. So should you do an emergency shutoff switch? On the section of the battery checklist that says, oh, I don't know, can the battery shutoffs disconnect? I'll just put not applicable for that whole section and move on with the checklist.
Hold on.
Yeah, scroll down. So your MID, your microgrid forming device or microgrid interconnection device, I guess that has two names. Used to be known as the manual or automatic transfer switch, and that's still a good enough name. In this case, for most of the technologies, for the SunPower, for the Enphase, for the Generac, what they've basically done is they've made a hub. It's where all the brains of the system lie, where all the microprocessing and the thinking is done, and this is what tells the battery charger what to do. This is what monitors where the power grid and tells the transfer switch to shut off from the power grid, et cetera, et cetera. It does a lot of things, and usually it tells the batteries that they should put out a voltage reference for the solar to keep the solar on when the grid goes down. Again, this is where the brains of the system are. So the same warnings that we have at the main meter usually go here. So there always is 3 sources of AC power in one of these brain boxes. And you have to tell people that because the electrician that comes on site to repair something in the future may not understand what they're doing. I know that most electricians have seen solar before, but there still are electricians out there who have not. And almost always, because this is where your main bus is, your AC bus, your backup bus, if you will, that will always have the potential for line power on the box, even if they shut off the main breaker, or even if shut off the main input from the street. So that's, again, the sticker is warning, terminals on the line and load sides may be energized in the open position. That is a valid warning. Next slide.
Is that the end of the code stuff?
No,
not the end
there's
of the
another
labels.
page. Okay, now at the battery stack, in general, for every device that you put there, if you put an AC disconnect outside and it's for the solar, label it solar AC disconnect. If you put a battery disconnect outside, label it battery disconnect. Everything that you install on your system needs a name and needs a label. So even your batteries, I know it's obvious to you and I and everyone else that you are installing a battery storage unit, but it needs a label that says battery storage unit. And that's just
Fire protection, right?
right. And that's code. There it is. Those are the code references that say that it needs to be. A lot of things I would like to see happen are backed up by code, which is great. And this next sticker, I've never failed anybody for not having it because it's just not that helpful, but it is code. Your AC voltage is going to be 120 volts almost certainly, or 240, depending on the unit. And the DC voltage in the box, that's usually on the label. So it's there if somebody wants it anyway, but there's a sticker that needs to go up in the front that has that. And for those of you who want to go to PV Labels or one of those other websites, this is what this is what the label looks like. I think there's a little bit more, maybe.
I think
That's it.
that's it. That's it on the code labeling. We're gonna jump over to the checklist, which I think I have.
And the beauty of the code labeling, it has not changed that much since the 2017 code, if at all, actually.
Okay.
All right, let's have a look at this checklist. This is the new checklist. And Neil is going to give you installers a date when this new checklist is going to be starting to be used in the field. It's arguably much more difficult checklist. So we've gone from a very hard checklist to pass to a very, very hard checklist to pass. And that is in part reasonably, it's because of the IREC codes. The sheetrocking is going to be a big deal. The smoke detectors are going to be a big deal. This is a very difficult checklist to satisfy all the requirements for. And I apologize in advance for that because that's just the way it is. So up front on the checklist, there's the usual project name, customer name, and stuff that you really just don't have to worry too much about.
Yeah, the first page is a lot of equipment check to make sure that what was on the application is actually installed.
Right, and that can be hard for the inspector, but that's not hard for you. You install what you install, and we'll work off that. The big thing on the front page is usually drawings. A lot of the drawings that installers are using come from the manufacturers, and some guy in California drew it. That's okay if it's accurate. If it's not accurate, that could be a problem. Usually I don't check the drawings too closely, but do make sure that if there's a problem that the customer and the green bank have accurate drawings. It would be because if you're on the battery, the best program, you're probably competent solar installers to begin with. So I really wouldn't worry about I would check, but I wouldn't worry that you're not going to use the wrong wire size and violate manufacturer specs. You're going to use the correct AC, the correct disconnects. You're not going to put a disconnect in place that doesn't have an AC rating, that sort of thing. And then I'm checking to make sure that what you installed is what you reported to the state program.
Yeah, and the original application in Salesforce.
Right.
I think we can just go into
straight.
Yeah, we discussed all the labels already, so we're not gonna rehash that. For now we'll just cover. So just if you could just cover the stuff that's not labels, basically.
All right. So everything that provides power needs a disconnect. Generally, that disconnect needs to be out of doors, and if at all possible, near the house electrical meter. That is why so many things go in the basement. and why so many things go in the basement near the main panel within easy line of sight. And then the installers just pop outside, put their disconnects out of doors near the meter in easy line of sight. If they're not in line of sight, if, for example, you're forced to put your disconnects on the other side of the house, then you need a plaque. And that plaque would tell first responders or whatever where the disconnects are. And then because you've put your disconnects away from your meter, you need a plaque at the meter and a plaque at the disconnects. And again, everything that you install, put a label on it. So if it's an AC disconnect, label it AC disconnect. Use permanent stickers. Don't use the little label maker that is great for indoors, but it will fade in a year if you put it outdoors, etc. Again, at the utility meter, multiple sources of AC power, a plaque, and usually there's a source sticker, and the source sticker is for the solar, not necessarily for the batteries. So,
Do you want to go down?
yep.
I'll go down.
Emergency shutoff switch, I'm a big fan. Again, it's not the open finger brake that you need for the PV. But it's a very quick and easy way to shut everything off. Now, it doesn't physically break any wires. It shuts it off the microprocessor, usually in the hub, or the brains device, I should call it, at the automatic transfer switch. But it counts, and it's good. It's a good way to shut things off, because a lot of times people will get on site and they're looking for that punch button. They want to hit that turn off everything, make it safe button. And then down at the electrical service panel. All right, so there is a problem that occasionally shows up with the neutrals and the grounds. So I know that you're all experienced battery installers. I need to tell you that you can only have one point where the neutral and the ground come together on any site. And usually that is going to move over to the hub, to the mid, the microgrid interconnection device is where that interconnection is going to be. As an inspector, I don't want to open that MID. So what I'm going to do is I'm going to pop open the electrical service panel, and I'm going to look to see that the separation of the neutral and the ground are made at what used to be the main panel. Now it's not. Now it's usually a sub panel downstream of the MID. So I'm going to make sure that the ground and the neutral are separated at that point. And then I'm going to assume that the ground and the neutral are connected together at the hub. And I'll check for all the other solar things like the overloaded bus bar or whatever. But if you have an MID, if you have a hub, you're almost certainly top fed. If you're not top fed, you're probably not backing up the whole house. And whole house battery backup is the way things are going.
Yeah, just to clarify, the inspection is really only related to the battery storage, and we won't be doing much, if anything, if there is solar, as far as our inspection goes.
Yeah, that's the one thing where this checklist is a little easier than the last one. The last one, I looked at the AC disconnect for the solar. I looked at the solar type things. On this checklist, on the 2020 checklist, I don't check any of those.
Yeah.
I don't check any of the solar piece. I only look at the hub. I only look at the batteries. I only look at the things that are ESS, energy storage systems.
Yeah. Ready to move on to the IRC?
I am.
We just kind of talked about this. I don't know if you want to do that again.
No, we can skip on past the microgrid.
Okay. I think we should just get into the IRC stuff, because that's probably the biggest thing, right? Unless there was something you really wanted to talk about.
No, I mean, I think we can go over everything. Again, the battery stack, I really, really recommend using the UL 1740, 9540, excuse me, the UL 9540 rated boxes. I don't think if this were my house, I would do anything else, to be honest. Because And you want to be able to say, I've done everything I can do to mitigate that risk. And like I said before, even if you've done everything right, even if you've installed it properly, even if you followed all the manufacturer specs and you've done your best to make sure that there's no damage, you could still have a fire. And that is a scary thing from a solar installer's standpoint. Because solar installers don't like roof leaks and they do not like fires. Next.
Yeah. All right. You want to go down to fires? Okay.
Okay, so the IREC code, if you have a 9540 rated box, you do not need to be 3 feet apart. So most of the newer boxes that are coming out are 9540 rated, and it should say so on the tag.
Yeah, and I think all the batteries in our program are UL 9540. So this really shouldn't be a problem. This is more like for informational if anyone wants to check on this.
But that hasn't always been true.
Right.
This is true for about the last 2 years. So there could be equipment that your distributor gives you because they want to sell it and get it out of their warehouse. That could be 3 years old. And if that's the case, check your tags. We've already covered permitted locations of the battery because that's an important part. And that you really don't have to worry about your individual storage units being more than 20 kilowatt hours. Your manufacturer will take care of that. And then, okay, this is a design thing. I know that the next one, your size of your individual units, how much are you allowed here and there and everywhere. You're going to more or less, like most installers do, design these systems through the manufacturer, and they're going to make sure you don't go over any of these limits. But the primary thing that you have to worry about is making sure that there's a Type X sheetrock installed in the area near the batteries. Does that mean that if you require Type X sheetrock, that you have to sheetrock the entire basement? That, again, we don't have all the answers, but at least the area around the batteries. You're going to need a smoke or heat detector installed near the batteries, and that the batteries are protected from impact. That is 100% a thing for the garage. And then workmanship, that's your catch-all. And that's when someone basically leaves a big gaping hole in the wall.
Yeah, just other miscellaneous things that might come up. Yeah.
Yeah. And usually that's not a problem, because I know that most or all of the battery installers in the battery installation program are top level installers that wouldn't do that sort of thing. Anything else?
I think that's the end of the checklist.
Are you sure?
Yeah.
Okay, that's the checklist.
Cool. So we left some time so for people to ask questions. If anyone has questions, just raise your hand and then I'll call on you and then you can just unmute yourself. And then, because we don't have too many people on here. So anyone have a question? Oh, sorry.
Someone submitted, Chris submitted one, and it says, from the front of the battery, how far does the clearance have to be regarding the bollard?
Bollard. I will look that up. I don't think that has to be very far. If you wanted me to just give you a number, I would probably say 6 inches. But I'm not even sure the code mentions that.
I don't know.
So I think that's installer's choice. Just so that the batteries are protected, but it doesn't, I don't remember there being any distance listed, but that's a really good question. Today is going to be a day of really good questions, I can tell you.
It says, but for servicing as well.
If I were installing batteries on the wall, what I would do is I would make sure that the doors can swing open. So I would put my bollards where I can make sure that I can service the equipment behind it and be very careful about that, because that could be a real problem. If you can't get the door off to add a battery here or there or do what you have to do, that could be an issue. What's your question there?
You said thanks.
Thanks. Okay.
I had maybe a boring one. Is it easy to tell, like if the sheetrock is already installed in the basement, is it easy to tell if it's rated?
No, it is
No.
not.
Okay.
It's supposed to be 5/8 and
Type
there's not,
X.
there's not an easy way to know that. If it's a drop ceiling, then definitely not.
Okay.
Or if it's like an unfinished, like open beam kind of thing, then that's not.
One in theory, sometimes on an installation, when we put up a wooden board,
Mhm.
but that doesn't do it any longer.
Yeah.
Even a fire type wooden board to mount on. In theory, one could mount that wooden board and put a piece of sheetrock over top of it, but now things are starting to get a little wonky. So we're not going to know if it's a 1/2 inch sheetrock. If it's sheetrocked, we're just going to have to say that the installer's done it right. But we don't really know whether it's fire protected sheetrock because we're not sheetrocking experts.
Did anyone else have a question? You can unmute yourself. I'm not sure who raised their hand there.
Hey Neil, this is Ed. I have
Oh,
my hand
hey.
raised. Hey,
Hey, go ahead.
so my question is about outdoor rated equipment. So there's a lot of new equipment coming on the market that is outdoor rated. They all have kind of specifics on, exactly where they can go. And is there anything specific about outdoors with regards to the material of the house or things like that, like shrubs and things like that that might be flammable, that anyone has to consider?
I would cut any shrubs away from the electrical equipment. I would follow the same rules as any other outdoor device, like an AC disconnect. If I were to put batteries out of doors, I think what I would do is I would do a metal buildup with some.
Yeah, but the newer technologies are going to be able to be installed like here, outdoors 3 feet away from doors and windows.
Right. I might get it off the house completely.
Yeah, but that won't, I don't think that, if the code says you can install it outside.
Yeah.
Yeah, my question is more specific to the code. Does it specify anything about, mounting it directly to the house, or, if it's a wood sided house versus vinyl, things like that?
Not that
Or
I'm
is it
aware
just
of.
away from the door? Okay.
Yeah. And people have been mounting inverters outdoors since they've been mounting inverters.
Okay.
An inverter is a completely different animal, I do admit, because your inverter is a fail-safe device. And I have a lot more confidence in inverters than I do in batteries.
But I have seen some inverters, like if the conduit's not attached properly, the water can get into the inverters. Can that happen with batteries too?
No.
No, it can't. Okay.
No, I don't know of any battery stack that can allow for pooling in the inside.
Okay.
Although there's new ones coming out every day. That's the number one worry about an inverter being outside, is that it can start collecting water inside, especially because a lot of the conduit comes straight from the roof. And sometimes it's the apprentice that installs the conduit. And just water dripping down, collecting an inch or two of water in the bottom of the inverter. I've seen that more than once. And that's really scary because water is a hazard for our normally fail-safe inverter.
Yeah, that happens sometimes. All right. And just so everyone knows, this checklist I think is linked on our website somewhere. But if you need a copy of it, I can get it to you. We're still discussing internally how this is going to be enforced. But on the checklist, you can see where'd it go? You can see that there's links here, and if you follow the links, it'll take you directly to the code, and you can read up on that there. And that's really like the main teeth of it. Like almost everything on here has a code reference, and I think that'll be useful. And then so since there's no other questions, I just want to say, Richard will be available for technical advice if you want to get in touch with Richard. So you would just email Lynn and me about that, and then we can coordinate a time with Richard when he might be available, and then we can all get together in a meeting, and that would just be for anything technical related, like procedure or other type things, Lynn and I and our team can handle.
I will gladly be responsible for code and answer the questions, how many amps are going down that wire. If it's a policy question, ask Neil.
Will, did you get all that?
Yep, we're good.
All right. Yeah, we ran a little early, which is fine. I think this was a great discussion. And if anyone needs another copy of the checklist, let me know, let Lynn know, and we'll get that to you. But I think it is linked on the website as well, along with the code labeling guide that we went over. Anyone have anything else? All right, excellent.